Hi, today we're going to be talking about white box testing. We are group number 2, and it is composed of Benjamin, Michael, and Alex. So, what is white box testing? Well, a definition found is it is the detailed investigation of internal logic and structure of the code. In white box testing, it is necessary for a tester to have full knowledge of source code. As opposed to with black box testing, where there's little to no care for the internal structure of knowledge of how it works, white box testing is focused on everything that's on the inside, as you can see from the image displayed on the screen. In white box testing, an internal perspective of the system, as well as programming skills, are used to design a variety of test cases. The tester gets to choose inputs to exercise pass through the code and determine the expected outputs. White box software testing process can be applied at a variety of levels, but most popularly, the unit and integration system are the most popular testing levels. Although traditional testers tended to think white box testing is being done at the unit level, it is used for integration and system testing more frequently today, along with a few other levels, which we'll be going ahead and addressing throughout this presentation. We're going to be starting with first the unit testing, the static and dynamic analysis, statement of coverage, branch coverage, security testing, and last, mutation testing.
The first level of white box testing is unit testing. In unit testing, the code is broken up into units, where the exact scope of a unit is left to interpretation. Specifically, a unit could be a function, a group of functions, perhaps all in the same class, etc. A series of tests is then designed for each of these units, to test them independently of each other. Of course, because of the complexity of most modern systems, unit testing cannot be 100% thorough, so plenty of other testing methods are still necessary. Moving on, we get to the second level, static and dynamic analysis. Static analysis is done in an IDE or text editor, not during runtime. To clarify, this may be the testing you are doing most of the time at your coding. Problems should be fixed by inspecting your code, source 1. Dynamic analysis involves checking the behavior of the program during runtime. This includes not only whether the program or whether the output is correct, but also potential issues such as resource hogging, hanging, etc. Various tools are available to aid in both static and dynamic analysis. Both types of analysis are quite necessary because they will each uncover different types of bugs.
The next level we have in white box testing is statement coverage. Statement coverage is often called the most basic of all white box methods because of its simplicity and what it seeks to accomplish. It basically just checks if all statements are executed, and that can be for one test or over multiple tests. And while this might sound a little confusing at first, it's actually very simple. Here we have an example of some code in C++ where we have an integer x being set equal to 1. Then the if statement x equals 2 is triggered, and we try to see if that passes or fails. And it's always going to fail, so the program is going to skip the cout statement and go to return 0. This specific piece of code would always fail because the cout statement would never be triggered, and so that statement would not be covered. The next level of white box testing we have is called branch coverage. Branch coverage is very similar to statement coverage. It is primarily different when the branches are empty. So quite often we have different branches going on in our program where we have an if statement or an else statement, and those can send the program off in different directions. So the primary difference of a branch coverage test and a statement coverage test is that in one test, all different possible branches have to be followed. So in one part of the test, the if statement has to return true. In another part of the test, the if statement has to return false. And here we have some code again, very similar to our previous example. This time x is being set equal to 2, and this time the if statement passes because x is indeed equal to 2 every single time. And so this cout statement will output and all these statements would be triggered. However, while this would pass the statement coverage test, it would fail the branch coverage test because there is never an instance in which if is equal or returns false, and so not all possible branches of the program are covered.
Security testing. Now, what is security testing? Security testing is the process of seeing how well a system can protect itself from unauthorized access, hacking, cracking, or any type of code damage, which deals with the code of application. So, in other words, to clarify this, security testing with the white box technique can be used to validate whether code implementation follows intended design, or to validate implemented security functionality, and to uncover exploitable vulnerabilities. Keeping in mind with the tradition of white box testing that this is all done internally. In this non-function testing, all type of the malicious attempts, they'll be simulated against the application to find the loopholes in the application. Security tests is a part of the higher level group of tests. It determines the vulnerability of the system by testing security, and we can protect resources and data from eventual intruders. The ultimate goal of security testing is to determine how the system reacts to unauthorized attacks. The next that we have is mutation testing. Now, what is mutation testing? It's an application is tested for the code that was modified after fixing a particular bug/defect. Now, what does that mean? In other words, mutation testing is defined from small changes that are made in a module or application. And then the original application is compared with the change. We'll go ahead and let's take a look at an image that'll go ahead and explain this a little bit better. So from the image that's on screen, you see there at step 1 that faults are introduced into the source code of the program by creating many versions called mutants. Each mutant should contain a single fault, and the goal is to cause the mutant version to fail, which demonstrates the effectiveness of the test cases. The next step is the test cases are applied to the original program and also to the mutant program. A test case should be adequate, and it is tweaked to detect faults in a program. Step 3 is compare the results of the original and mutant program. And then step 4, if the original program and mutant programs generate different outputs, then the mutant is killed by the test case. Hence, the test case is good enough to detect the change between the original and the mutant program. If the original program and mutant program generate the same output, mutant is kept alive. In such cases, more effective test cases need to be created that kill all the mutants. So it's just a better way that we'll be able to test the output and compare those results from the original application.
Some of the advantages of white box testing are, first, that it requires the tester or testers to become quite familiar with the code, and so they will have a much better understanding of the types of inputs to use in, for example, unit testing. In addition, white box testing can help to find paths that are not being used, using, for example, statement and branch coverage, which will be discussed later. This can help to identify parts of the code that either may no longer be necessary or are not reached because of some error in logic. This can be taken advantage of by either removing that part of the code or by altering a decision point so that the branch is used properly. Some of the disadvantages of white box testing are, first, that it may be more costly than other forms of testing, because those who are involved need to become quite familiar with the code. And second, like all forms of testing, this method is not perfect, and in a project of any appreciable size, is highly unlikely to find every bug.
So, how does white box testing compare to black and gray box testing? Well, white box testing is, as we've discussed throughout this presentation, testing the software product with complete knowledge and understanding of the application's internal structure. Again, there's that key word, the internal structure. While the black box, as you can guess, is the complete opposite. It's testing the software product with no knowledge or access to the internal structure of that application. While gray box is a mixture of the two of them, the testing the software application with limited understanding, access to the product's internal structure. Now, one important thing to remember that is key to this white box testing is white box testing's basic procedures require the tester to have an in-depth knowledge of the source code being tested. The programmer must have a deep understanding of the application and know what kinds of test cases to create so that every visible path is exercised for testing, while with the black and gray box testing, that isn't the case.
The next question we have is when to use white box testing. It is a general use testing method and it's useful for a number of problems. Some listed out by BJ Rawlinson on Stack Overflow were: there is a business need or goal to increase code coverage measures, such as they want to increase their efficiency. There is a suspicion that some area of the program may be under tested, or for security or reduced risk. According to BJ Rawlinson, security flaws are quite often more easily found when doing white box testing, as you can look directly at the code and spot issues directly. How is white box testing used in the software lifecycle? White box testing is useful in any part of the software development lifecycle and can really only be used after code is developed, since in order to use white box testing you have to be able to see the code. It is particularly useful during unit testing, and it should be a constant process as new code is developed.